Ladies and gentlemen, welcome to the 2013 American Geophysical Union Honors Tribute. Now entering the ballroom are the 2013 awardees and prize winner, who are being honored for their vision and foresight, commitment to furthering education in the earth and space sciences, outstanding achievements in science journalism, and efforts to engage a broad audience on the topic of climate change. Now our 2013 class of fellows. Nominated by their colleagues, these individuals are widely acknowledged as leaders in their fields. Only 0.1% of AGU membership can be elected in any given year. This evening, 62 scientists will be honored with the designation Fellow of the American Geophysical Union. And finally, our medalists, pioneers whose example of dedication, professionalism, and generosity has guided students, inspired researchers, and led to valuable collaborations that have greatly benefited humanity. Please welcome the President of the American Geophysical Union, Carol Finn.
Thank you. The Honors Tribute is an event we look forward to each year with tremendous pleasure and anticipation. From its very founding, the American Geophysical Union has paid special tribute to members whose theoretical and experimental work has expanded our knowledge of the Earth and beyond. With this event, we celebrate the pursuit of knowledge, the spirit of discovery, and each individual's commitment to the highest ideals of our profession. Now, if you will direct your attention to the screens, we will begin our program with the 2013 awards and the Climate Communication Prize, presented by AGU Executive Director and CEO Christine McEntee.
I am excited to be here tonight to present the 2013 American Geophysical Union Awards and Prize to such a distinguished group of scientists, leaders, educators, and communicators. With these awards and the prize, AGU seeks to recognize those whose hard work and dedication have set the standard of excellence for our 62,000 members around the world. These awards and the prize recognize individuals who have demonstrated excellence in scientific research, education, communication, and outreach, highlighting the importance of Earth and space sciences. Many of the individuals we honor here tonight are scientists noted for their passion for research, generous collaboration with colleagues, and dedication to their institutions and students. Some contribute to the understanding of science from other fields, such as journalism and new media. All further our appreciation of the power of science to improve our lives and our communities. I am also proud to announce the new Ambassadors Award, which was created to honor members for their achievements in leadership, outreach, service, and talent pool development. Achievements that extend beyond those recognized by traditional scientific discipline awards. This award will further AGU's strategic objectives to promote collaboration and innovation, inform society about the Earth and space sciences, and build the global talent pool. Nominations will open January 15th, and the first of these awards will be presented at next year's honor ceremony.
Good evening, everyone. This year, we also added the Science for Solutions Award. This new award recognizes the innovation and dedication of students and postdoctoral scientists who have put their knowledge to work on important societal issues. AGU's mission is to promote discovery in Earth and space science for the benefit of humanity. When our members apply their expertise directly to the problems that face society, they demonstrate the power of science to make the world a better place. Will each recipient please come to the stage as your name is announced?
Our first award, the David Perlman Award for Excellence in Science Journalism News, is presented to Paul Voosen. Paul Voosen receives the David Perlman Award for his article, Glacial Ghosts Set Sea Level Trap for East Coast, which uses the events of Superstorm Sandy to paint a vivid portrait of sea level rise and its deeply local context. The Walter Sullivan Award for Excellence in Science Journalism Features is presented to Tim Folger. Tim Folger receives the Walter Sullivan Award for his gripping account of the science and the human cost of tsunamis, and a warning that the Japanese disaster may soon be repeated. The Robert C. Cowen Award for Sustained Achievement in Science Journalism is presented to Erna Akuginow and Geoffrey Haines-Stiles. Erna Akuginow and Geoffrey Haines-Stiles receive the Robert C. Cowen Award for producing accurate, compelling and accessible science documentaries, live events, print and new media, from Earth to Mars and the whole cosmos. The first AGU Science for Solutions Award is presented to Solomon M. Hsiang. Solomon M. Hsiang receives the Science for Solutions Award for groundbreaking research at the interface of climate and social science. The Excellence in Geophysical Education Award is presented to Tamara Shapiro Ledley. Tamara Shapiro Ledley receives the Excellence in Geophysical Education Award for her tireless work in bringing to thousands of teachers data and tools for understanding Earth science and for her leadership in climate literacy. The International Award is presented to Jaime Urrutia Fucugauchi. Jaime Urrutia Fucugauchi receives the International Award for his outstanding scientific contributions, unselfish collaboration, and distinguished service to the international scientific community. The Athelstan Spillhouse Award is presented to Iain Stewart. Iain Stewart receives the Athelstan Spillhouse Award for his truly exceptional work over the last decade in communicating the excitement of modern Earth sciences to the general public. The Charles S. Falkenberg Award is presented to Chelle Gentemann. Chelle Gentemann receives the Charles S. Falkenberg Award for her major contributions to the generation of sea surface temperatures from satellite sensors and to the study of the upper ocean. The Edward A. Flynn III Award is presented to John L. LaBrecque. John L. LaBrecque receives the Edward A. Flynn III Award for his dedication to the ongoing international support of space-based observations of the Earth and its potential fields. Our final award, the Climate Communication Prize, is presented to Kevin E. Trenberth. Kevin E. Trenberth receives the Climate Communication Prize for his decades of climate change communication, unrivaled in quality, diversity, and longevity, and encompassing basic research, public education, and many media outlets.
The 62 men and women selected this year as Fellows of the American Geophysical Union join a highly influential group of scientists at the very peak of prolific careers in Earth and space sciences. Each year, only one of every 1,000 AGU members earns this special recognition. The election process for AGU Fellows is challenging because we are choosing from among nominated scientists that are all outstanding. Of course, this is an excellent challenge to face. AGU Fellows are pioneers and visionaries with exceptional scientific knowledge within their respective fields. Their scientific breakthroughs and the paradigm shifts that they have led have had an impact that is recognized and admired, not only by their peers, but by the public at large. This year, the elected class is one of our most diverse in terms of scientific contributions. Under the sea, in the atmosphere, around and in the Earth, and into the deepest reaches of space, they push back the boundaries of our knowledge and open up endless new possibilities. It is a special privilege to be here tonight to lead all of you in honoring our newest AGU Fellows. Their dedication to science, their commitment to discovery, and their never-ending quest for truth is an inspiration to us all. These men and women are charting the course for our collective future. Will the fellows please come to the stage as your names are announced?
Hsiang An, for exceptional contributions in understanding Asian monsoon dynamics and global climate change. Christopher John Ballentine, for his leading geochemistry work in the application of noble gas isotopes to the origin and evolution of Earth's volatile elements. Andrew Binley, for outstanding contributions toward the fundamental understanding of hydrological model uncertainty and for pioneering the field of hydrogeophysics. Gordon Bonan, for highly influential work on the coupling of terrestrial ecosystems with the atmosphere and feedbacks with climate change. Roland Bergman, for elucidating the role of the micromechanical properties of the ductile lithosphere to understand the earthquake deformation cycle. Paige Chamberlain, for his pioneering application of stable isotopes across the geophysical sciences. Alan H. Duvall, for outstanding contributions in marine biogeochemistry, especially elemental cycling in low oxygen water and sediment environments. Herb Dragert, for breakthrough geodetic discoveries that led to fundamental advances in the understanding of subduction zone geodynamics and fault behavior. Thomas Duffy, for fundamental contributions to understanding the properties of deep Earth materials and the constitution of Earth. Cynthia Ebbinger, for fundamental work on the evolution of continental rifts towards seafloor spreading in East Africa and afar. Robert E. Ergen, for developing instruments, theories, and models of electric fields to investigate auroral acceleration processes at Earth, Mars, and Jupiter. Graham Feingold, for highly innovative and insightful research on climate-related processes of the cloud aerosol precipitation system. Catherine H. Freeman, for innovative and sustained contributions to the fields of isotopic and molecular biogeochemistry and paleoclimatology. Joan Gomberg, for fundamental investigation of triggering in theory in earthquakes and in slow earthquakes, and for public outreach in earthquake hazards. Philip R. Goody, for seminal contributions to solar physics and to the development of a revolutionary ground-based solar telescope facility. David C. Goodrich, for seminal advances in arid and semi-arid hydrology and in eco-hydrology, interdisciplinary leadership, and communication of science to elected officials. Denis Hatzfeld, for setting high standards in field seismology and for exploiting geophysical data to understand how continental lithosphere deforms. Barbara Mary Hickey, for innovative research on ocean dynamics and physical links to ecological sustainability in coastal upwelling regimes. Eileen E. Hoffman, for her pioneering work in modeling physical-biological interactions. Joseph Ubar, for seminal advances in modeling the dynamics of Earth's ionosphere, magnetic reconnection, and the theory of kinetic fluid plasma instabilities. Susan E. Humphreys, for sustained and exemplary contributions to our understanding of volcanic and hydrothermal processes at mid-oceanic ridges. Catherine Louise Johnson, for significant contributions to understanding the magnetic fields and interior structures of the Moon and terrestrial planets. Gregory C. Johnson, for major contributions to observing and understanding ocean circulation, dynamics, and heat storage, and their influence on Earth's climate. Paul R. Cradle, for sustained and innovative contribution to the understanding of cloud electrification and lightning. David W. Lee, for novel contributions to proxy development and reconstructing Pleistocene-Holocene climate. L. Ruby Leung, for extraordinary leadership in the development and use of regional climate models to advance climate change and hydroclimate research. Lisa A. Levin, for significant and diverse interdisciplinary contributions to the understanding of benthic marine processes within earth sciences. Peter S. Liss, for his pioneering and continuing research on air-sea exchange of gases and its effects on marine biogeochemistry, atmospheric chemistry, and climate. Natalie M. Mahowald, for fundamental contributions to our understanding of mineral aerosol impacts on global biogeochemical cycles and the climate system. Alan C. Mix, for his pioneering and enduring contributions to our understanding of ocean history and climate. Russell Monson, for discerning the ecological and atmospheric function of plant-emitted hydrocarbons and advancing understanding of carbon cycling in forested ecosystems. J. Casey Moore, for characterizing the structure, hydrodynamics, and evolution of subduction accretion complexes and the underlying subduction thrust interface. Kenneth Mopper, for his pioneering research in the biogeochemistry and photochemistry of dissolved organic matter in the sea and fresh waters. Andrew A. Nyblade, for outstanding contributions toward understanding the structure and dynamics of the mantle beneath the African continent. Katsushige Obara, for discovery of non-volcanic tremor and fundamental contributions to the understanding of slow earthquake phenomena. Tim Palmer, for fundamental understanding of the predictability of weather and climate and for pioneering the tools to estimate such predictability. Charles K. Paul, for leadership and scientific contributions in marine gas hydrates, seafloor morphology, and biological seep communities. Michael Perfit, for groundbreaking petrology and geochemistry on mid-ocean ridge and island arc magmatic systems and their temporal and spatial variations. Donald K. Pirovich, for fundamental work in sea ice optics and understanding of the ice albedo feedback to climate now active in Arctic sea ice regions. John W. Pomeroy, for outstanding contributions to understanding the process and to the modeling of the hydrology of cold regions. Nancy N. Rabelais, for her pioneering and sustained contributions to understanding hypoxia in the ocean, with emphasis on the northern Gulf of Mexico. Eric J. Rignot, for innovations in detecting change of the polar ice sheets, leading to the first continent-wide assessment of mass balance. David Rind, for fundamental contributions and leadership in the study of global climate and climate modeling. Andrew P. Roberts, for his pioneering work in environmental magnetism and climate change, and for developing advanced new methods in rock magnetism. William I. Rose, for his pioneering and fundamental contributions by direct and remote characterization to our understanding of ash and gases in volcanic plumes. James M. Russell III, for leadership in developing and operating experiments, for answering questions about Earth's atmosphere, and for the sustained impact of his work. Christopher Lee Sabine, for groundbreaking research and scientific leadership on the marine carbon cycle. John Selker, for providing a complete picture of contaminant and biological factors in hydrologic processes from theory to instruments. Jeff Severinghaus, for his use of innovative measurements of gases in ice cores to understand the causes of climate change. Donald I. Siegel, for seminal contributions to understanding the hydrology and biogeochemistry of peatlands and deep aquifer systems. Rudy Slingerland, for pioneering the quantitative modeling of coupled sedimentary, tectonic, and geomorphic processes. Chris Soulsby, for path-breaking studies linking soil properties, runoff generation mechanisms, catchment water storage, and salmon survival in rivers. Barbara J. Turpin, for visionary thinking about the role of aqueous chemistry in the formation of organic aerosol. Bin Wong, for seminal contributions to the advancement of scientific understanding of the dynamics and predictability of monsoon and tropical climate. Warren M. Washington, for fundamental contributions and leadership in the study of global climate and climate modeling, and for his inspiring mentorship of our young future scientists. Paul Wenberg, for seminal contributions to our understanding of atmospheric chemistry. Peter R. Wilcock, for significant contributions to the mechanics of sediment transport in gravel-bedded river systems and applications to river restoration. Warren Jackman Wiscombe, for fundamental advances in radiative transfer modeling, outstanding leadership in promoting climate science, and exceptional service to the AGU community. Ellen Wall, for sustained and innovative contributions to understanding the geomorphology, evolution, and restoration of mountain, bedrock, and tropical rivers. On Yin, for outstanding unification of field observation and quantitative theory to achieve breakthrough insights into the evolution of mountain belts. Peter K. Zeitler, for his pioneering contributions to thermochronology and its application to a new understanding of orogeny. Hsiang, for fundamental contributions to our understanding of rotating fluids and dynamo theory and their application to the cores of Earth and other planets.
Thank you, and congratulations again to all of you. Returning to the stage to present our most prestigious honors is AGU President Carol Finn.
Each of our medalists have had long and distinguished careers. I'll highlight only a few reasons they're being honored, and I encourage you to read their complete citations in your printed program. Will each medalist please come to the stage as I announce your name? Our first honoree has been a central figure in mantle dynamics for the past 30 years and is responsible for many of the fundamental advances in our understanding of mantle structure and flow and their connection to the geological record. His argument for whole mantle convection remains a foundation for global geophysics. His development of kinematic and dynamic models of global mantle flow provided a new framework for numerical simulations of mantle convection. His inspired research moved the field away from the 2D Cartesian models toward global models that could be related to seismic and rheological structure and directly compared to global data sets. In collaboration with other scientists, he has demonstrated that plate bending stresses of subduction zones play a critical role in plate dynamics and the overall driving force for plate tectonics. Ladies and gentlemen, it is my pleasure to present the Inga Lehman Medal for outstanding contributions to the understanding of the structure, composition, and dynamics of Earth's mantle and core to Bradford Hager.
Okay, thank you, Madam President, for your help in finding my sheet of paper here. And special thanks to Jerry Mitrovica for his very generous citation. Any creative contribution I've achieved is a tribute to the exceptionally talented and passionate students, postdocs, and colleagues who have inspired me through my career. Thank you all. At Harvard, my fellow graduate students both tutored and challenged me, including giving me a practice general's exam that made the real thing seem really easy. Rick O'Connell handed me an outstanding thesis topic, and 4 future medalists, future Lehman medalists, including John Woodhouse, Barbara Romanowitz, and Rick, were there, giving me a chance to romp with the big dogs. Adam Jawanski involved me in his original paper presenting a global tomographic model of the mantle, fixating me on the challenges of reconciling seismology, geodesy, and geodynamics. At Caltech, coffee hour discussions with Don Anderson, Hiro Kanamori, and a brilliant cohort of graduate students were exquisitely stimulating. Working with Rob Clayton on the geodynamical implications of his astonishing tomographic models provided a downright mystical experience. They set the stage for Mark Richards and me to explain Earth's geoid. Another stroke of good fortune was the advent of GPS. At last, I could do physics outside. Tom Jordan welcomed me to MIT, where Tom Herring, Peter Molnar, and others initiated GPS surveys measuring mountains being built and earthquake strain being accumulated and released. Finally, I want to note how special it is to receive AGU's medal honoring Inga Lehman, not only because her discoveries ranged from the inner core to the uppermost mantle, but also because she led the way for women in our field. My mother, who had a wonderful mind, was not allowed to attend college because of her gender. In contrast, my daughters have been welcomed into science, free to run as far as their abilities will take them. I thank the many women in my life, especially my wife Patty, who continue to inspire me. Thank you very much.
Congratulations, Brad. Our next honoree has made trailblazing contributions in the study of radiation, the prime driver in Earth's energy budget and in cloud physics, both of which are fundamental to our understanding of climate dynamics and atmosphere surface interactions. He has been a pioneer in the study of light scattering by ice crystals and cirrus clouds, where his unified theory encompassing light scattering and absorption by ice crystals of all sizes and shapes has transformed the field of remote sensing of cloud composition and structure. Among his many achievements, he has shown that high cirrus clouds are critical and can amplify surface temperature increases resulting from greenhouse radiative forcing. Please join me in welcoming the recipient of this year's Roger Revelle Medal for outstanding contributions in atmospheric sciences, atmosphere-ocean coupling, atmosphere-land coupling, biogeochemical cycles, climate, or related aspects of the Earth system. Kuo-nan Liao.
Thank you, Madam President and colleagues. It is with great pleasure and humanity that I accept the AGU 2013 Roger Revelle Medal. First, I would like to thank the selection committee for recognizing my contributions to radio transfer and related climate and remote sensing fields. Radio transfer is an interdisciplinary subject initially studied by astrophysicists and later by planetary scientists and meteorologists for atmospheric applications. The concept of radiative forcing, which measures the impacts of the anthropogenic greenhouse gases and aerosols and cloud feedback on global warming and climate change, requires radiative transfer analysis. Developing remote sensing techniques to infer atmospheric compositions and surface properties must follow the principle of radiative transfer. I'm glad that I have been able to make some contributions to radiative transfer and light scattering by ice crystals and aerosols and their application to climate and remote sensing. I would like to thank and extend my gratitude to Wilf Brusa for his unwavering support and encouragement in my pursuit of academic and research excellence. I also thank Richard Goody, Bob Dickinson, Mike Wallace, and a number of colleagues, including Dave Atlas and Michael Michenko, for their gracious support. Over the last 30 years, I have had the privilege of working with a number of bright and talented graduate students at the University of Utah and UCLA, who complemented my strengths in research. They deserve to share in equal measures any recognition I have received, including this great honor from AGU. Finally, I wish to note that I served as chair of the Atmospheric Sciences Fellows Committee during the past years. I'm particularly pleased to see that 12 of our recommended candidates were elected by AGU. My congratulations to them as well. Thank you very much indeed.
Congratulations, Kuonan. Our next honoree is one of the foremost petrologists of our time, a leading authority on the thermodynamics of metamorphic reactions, who has brought both theoretical and experimental petrology back to the forefront of earth science. His work revolutionized our understanding of the distribution of trace elements between melts and solids in the earth, and brought order to a literature of experimental data that allowed no satisfactory quantitative modeling of melting processes in the mantle. His newest research offers a framework for understanding the melting processes that shaped the earliest evolution of the Earth. Ladies and gentlemen, the recipient of the Harry H. Hess Medal for outstanding achievements in research on the constitution and evolution of the Earth and other planets, Bernard J. Wood.
President Finn, friends, I'm truly delighted to receive the Hess Medal. Expressing one's feelings on receiving such an honour adequately is difficult, but pride, humility, and gratitude for a long career in science and for many great friendships that I made in science all occur. It started with my postdoc mentor in Manchester, W.S. Mackenzie. He thought I needed to see a little more of the scientific world, and in 1973, he sent me to Berkeley to work with Ian Carmichael. Now, Berkeley in 1973 was kind of an interesting place. Anti-war demonstrations, Watergate hearings, and I thought it was a typical American town. Ian beat me up intellectually, which he did to everybody, and then after about 6 months he declared that I was more or less educated, and I was able to return cheerfully to a faculty position in Manchester. In 1981 I moved to Northwestern, where I stayed for a very, very happy 8 years. Working around a strong geophysics group, I found I was able to apply my knowledge of thermodynamics and petrology to problems of whole Earth structure, particularly to seismic discontinuities and phase transitions. Importantly, Cy Schlanger taught me the secrets of being an effective department chair. In 1989, Steve Sparks and I were offered positions in Bristol, back in the UK, and we were offered 10 faculty positions to fill and challenged to build a major department. This was a kind of an irresistible challenge, I must admit, and I confess to still being very proud of the results of our efforts. Now, in the context of this award, I must finish by mentioning an interview I had for a junior faculty job at Oxford in 1972. Ron Oxborough asked how plate tectonics would influence the direction of my research. I replied that I couldn't think of any way that it would. I didn't get the job. But I hope that both Ron and Harry Hess would think that I've progressed somewhat since then. Thank you very much.
Congratulations, Bernie. Next, we honor an exemplary scholar who has opened up new frontiers in Earth system modeling. He has led research that has broadened our understanding of the role climate and soils play in regional and global scale hydrology, introduced particle filtering and model averaging approaches to better characterize modeling errors, and presented a multi-criteria approach to model calibration. His research teams introduced artificial neural networks to model the rainfall runoff transformation work that is arguably the most successful attempt to predict stream flow dynamics. Let's welcome the recipient of the Robert E. Horton Medal for outstanding contributions to hydrology, Soroush Shahrouzian.
Well, thank you, Carol, and thank you, AGU. for this great honor. I am grateful to Jasper Root, first of all, for leading my nomination and the colleagues who provided supporting letters. AGU was the first professional society I joined as a graduate student in the mid-1970s. A big part of my professional growth benefited from AGU activities. Much of the exposure given to my research with my graduate students and my colleagues were through AGU publications and meetings. It's been really a great journey to tonight. Going back, the education I received in the US after arriving from Iran came from two of the finest institutions in California, Cal Poly San Luis Obispo and UCLA. My advisor, John Dragert, provided me the opportunity to learn and explore hydrologic modeling. Bill Ye taught me all I needed to know about water resources systems and groundwater hydrology. My academic career started at Case Western Reserve University, and thanks to Yakov Haines for giving me the opportunity to join their faculty. My 20 years at the University of Arizona provided me an incredible chance of experiencing the true meaning of interdisciplinary research with great many, especially Hoshin Gupta, Shlomo Newman, Lucianne Duckstein, Ernie Smerdon, Jim Shuttleworth, Roger Bales, Juan Valdez, and Malcolm Hughes, among many others. My present institution at the University of California, Irvine has given me a unique chance again to pursue new directions in hydroclimatology and remote sensing. While the honor comes to me tonight, it's a shared prize with many former students and postdocs over the past 40 years, and in particular Guinyan Duan, Gangshao Gao, Colin Shu, Bishar Imam, and David Goodrich, who was a recipient of the fellows tonight. I would be remiss if I did not acknowledge the role of a few special colleagues, Steve Burgess, John Shockey, and Dave Doughty, and the funding agencies that have supported my research, NSF, NASA, NOAA, and the Army Research Office, as well as UNESCO on the international side. Finally, my wife of 38 years plus, Shireen, she's been a true partner in my life, and my sons, Jamshid and Armin, have been source of pride and joy for us. Thank you very much.
Congratulations, Haroush. In conjunction with the United States Navy, AGU established the Morris Ewing Medal to recognize significant original contributions to the scientific understanding of the processes in the ocean for the advancement of oceanographic engineering, technology, and instrumentation, or for outstanding service to marine sciences. I would like to call Dr. Scott Harper of the U.S. Navy to the stage to assist in the presentation. You're already here. Very cool. I'm supposed to say more. I walked too soon. Looks very nice on you. This year's recipient has been enormously influential in changing our perception of the El Niño from a local phenomenon to one phase of a natural oscillation dependent on ocean-atmosphere interactions. His research forms the basis for operational and experimental forecasts of El Niño, as well as for seasonal forecasts of temperature and precipitation widely used by the agricultural, energy, transportation, and other sectors. His work has also established the strategy and rationale for the vast array of instruments now maintained in the tropical Pacific Ocean. Ladies and gentlemen, please welcome the recipient of the Morris Ewing Medal for 2013, Mark A. Kane.
Well, thank you, Carol. And I have to add something to what I was going to say, because one of the things I've learned, and I guess I knew a bit, but is that the array of instruments that we have in the tropical Pacific is in fact not being maintained. And it was a tremendous effort on the part of a large number of people to do the science that justified putting this array in, and an even greater effort to, in fact, do the instrument development and deploy these instruments. And it's one of the most amazing long time series we have in oceanography, and it's kind of a shame that it's being degraded now. Sorry to have to say that. Okay, what I wanted to start with is to begin by paying tribute to Klaus Wertke, who is the godfather of ENSO studies and is a particular hero of mine. Klaus passed away earlier this year. He basically pointed me in the direction to look at what Bjerknes's work as the way forward. Klaus was always very definite about things, okay? And in fact, his own work with tide gauge data showed that ocean dynamics was the proper explanatory explanation for ENSO's oscillatory nature. And I think that my best known work can fairly be described as just translating what Bjerknes and Wertke worked out into a numerical model. I want to thank George Philander for my being here tonight, because if he hadn't nominated me, then somebody else would be here tonight, okay? More important, I'm very grateful to George for his friendship and his support over many, many years. All my best work has been collaborative with wonderful colleagues, including terrific students, and I can't possibly name them all, but I must mention Ed Sarachek and Steve Zibiak. My work on equatorial wave theory was done with Ed, and Steve was my first student, and our work on simulating and predicting El Nino is the obvious reason I'm here now. I also must thank my foremost collaborator in life, my wife Barbara, for her support over most of a lifetime. Now, in the beginning of my career, equatorial oceanography and ocean-atmosphere interactions were a backwater, kind of outside the oceanographic mainstream. Fortunately, there was a great group of us in this tropical area, and we had the tremendous fun, really, of developing this subject almost from scratch. And so, while honors go to individuals, this honor should be taken as recognition of the extraordinary collective accomplishment of our tropical oceanographic community. I have the great good fortune now, and for the last 30 years just about, to work at Lamont. Lamont was founded by Doc Ewing, in whose name this award is given, and it continues to be the scientific commune that Maurice Ewing created. And so I cherish this medal all the more for the Ewing connection, and I thank the Office of Naval Research for making it possible. Thank you.
Congratulations, Mark. Our next medalist is a world-renowned pioneer and leader in space science. He has developed original theories for major observational problems and tested and refined those theories using sophistical numerical simulation codes and that he helped to develop. Many of his revolutionary advances, including the breakout model for coronal mass ejections, the S-Web model for the slow solar wind, and the thermal non-equilibrium model for solar prominences, have opened up new areas of study and shaped the course of space physics. Indeed, the breakout model is the leading theory for why coronal mass ejections occur and may one day serve as the foundation for more accurate space weather predictions. Ladies and gentlemen, the recipient of the John Adam Fleming Medal for Original Research and Technical Leadership in Geomagnetism, Atmospheric Electricity, Aeronomy, Space Physics, and Related Scientists, Spiro Tio Ojos.
Don't worry about it. Thank you, Carol. Also, thank you, Jim Klimchuk, for writing this far too generous citation. And thank you very much, all my AGU colleagues, for honoring me with the Fleming Medal. When I consider the list of outstanding scientists, brilliant scientists, who have been awarded the Fleming Medal, I am honored that you have selected me to be in their company. I am especially proud that this award is from the AGU because only later in my career did I join the AGU. This was by far the best professional decision I ever made. I wish I could tell you it was due to brilliant insight, but no, it was just sheer luck. As a result of joining the AGU, I've made some wonderful colleagues, many great colleagues. I've always loved doing research. That's what I live for. But working with my AGU colleagues has made that research a true joy, a true pleasure. Also, moving to the AGU gave me the opportunity to kind of change the direction of my science and to participate in what I consider to be the most exciting science that's being done at present. When I started my career, physics was about discovering the laws of nature. That's what we were doing back then. But now, the frontier work is really at trying to understand how those laws, how the laws of nature affect humanity. And it's exactly what we do here at the AGU. So I am so proud that my, whatever they are, my contributions to that science have been recognized with the Fleming Medal. Of course, all my results are due to the help of others. First and foremost, I would like to thank my family, my two sons, and especially my wife, Mary. Her steadfast support, her infinite patience have been truly amazing. I have also been very fortunate to have three close colleagues, Jim Klimchuk, Judy Carpenter, and Rick DeVore, who I have worked in partnership for many years and who are responsible for any of the successes that I may have had. They have made every aspect of the work, even the writing proposals, a true pleasure. Finally, I must thank NASA. NASA funded me when I was a graduate student. They funded me through my career, and recently they've even gone so far as to hire me. I think they've done that just to keep me out of trouble, but who knows. But whatever it is, thank you so much, NASA, so I continue doing my research. And thank you all. Let's have some fun.
Congratulations, Spiro. Each year, the James B. McElwain Medal is awarded to outstanding early career scientists for significant contributions to the geophysical sciences. The first recipient of this year's James B. McElwain Medal has already become one of the world's leading experts in the field of atmosphere, land, surface interactions. Broadening our understanding of droughts and heat waves, she demonstrated for the first time that the lack of evaporative moisture to the atmosphere as a result of dry soils was a critical factor in generating extremely hot conditions, contrary to the prevailing opinion that heat waves only result from anomalies in large-scale circulation patterns. She has been the driving force behind the recognition of the importance of soil moisture for controlling summer climate, in particular for climate extremes. Ladies and gentlemen, please welcome Sonia Senaviratne.
Yeah, thank you very much, Mrs. President. And I should really thank also Nicolas Gruber at ETH Zurich for this very kind citation. He's an outstanding and inspiring scientist, and as well as a great colleague at ETH. Of course, I'm extremely thankful to AGU, and I'm also thankful to all those who supported my nomination, and within AGU to the Michael Wayne Medal Committee, who chose me for this great honor, so I'm very deeply humbled. This means also a lot to me because actually the first scientific conference I attended was an AGU conference. It was several years ago, and it did give me a lasting motivation to stay in science, so it was, I still remember it very well. I was extremely lucky to cross the paths of many people who enabled me to be here where I am today, so I'm very aware of this. I can only mention a few here. I wanted to mention Christoph Scher, who was my PhD advisor at ETH. He strongly encouraged me to pursue an academic career, and this really made a big difference for me. I was also extremely fortunate to work at NASA JSFC with Randy Koster, who is a scientist I learned very much from and who continues to be a role model for me, and I'm always impressed by his research. I'm also very grateful to have worked on the IPCC SREX report. That was a great experience, and especially because I worked on this report together with Neville Nichols from Monash University, with a person of very, very large knowledge and experience, who also was extremely generous and kind. I should also obviously mention all my students. I was blessed with a large number already of very talented students and postdocs who have worked in my group, and several of them are here in the room. And really, I would like to thank all of you for what you have contributed to our research, and it's fantastic. Thank you. I would also like to mention the great research conditions we have at ETH Zurich, and also the fantastic support I've received from my colleagues there. And it was a great chance for me for starting my career. Finally, I would like to thank my husband, Ludovic, for his constant love and support. This makes a big difference, especially when you have a young family. And both he and our little Daphne helped me remember the important things in life, and also that our commitment to climate research is essential for future generations. So thank you very much.
Congratulations, Sonia. Our second McElwain medalist is being honored for his discovery of the post-perovskite phase of MgSiO3 for a new class of sound velocity measurements under lower mantle pressure temperature conditions that have changed our view of whole Earth chemistry, and for other fundamental contributions that have furthered our understanding of Earth's deep interior. His seminal contributions have profound implications for mineral physics, seismology, geodynamics, and geochemistry. Ladies and gentlemen, please welcome Motohiko Murakami.
Thank you very much for this tremendous honor. It is a great honor for me to receive this medal. I want to particularly thank my citationist, J. Bass, for all of his support. And I also sincerely thank AGU for this recognition and my nominators for the supporting letters. I would not certainly be standing here today if I had not met many teachers, mentors, colleagues, and friends who always helped and encouraged me all along the way. My undergraduate advisor, Shigenori Maruyama, strongly inspired my research interest in deep Earth, and my PhD advisor, Kei Hirose, introduced me to the new world of high-pressure experiments. I also had the great luck to work with J. Bass after my PhD. I learned so much from him about the elasticity measurement of the mantle minerals through a great collaboration with Stas Shinogekin. Thank you, Jay and Stas, for your support, time, and knowledge. At Okayama University, I have particularly enjoyed interacting with Eiji Ito, a great master of high-pressure experiments, together with Tomo Katsura, Akira Yoneda, Daisuke Yamazaki, and Takashi Yoshino. Thank you for your energy and passion. Now I have been working at Tohoku University almost 6 years now with many talented scientists and students. My special thanks go to Eiji Otani for his generous guidance and continuous encouragement throughout my academic career. Over the last years, I have had the wonderful opportunity to meet a number of outstanding mentors and scientists who significantly influenced me, such as Shunichiro Karato, Guillaume Ficquet, Alex Goncharov, Jan Matas, John Helland, and John Sandercock. I am so grateful to them all for their guidance, mentorship, and enthusiasm. Most important, I want to thank my parents, Katsuhiko and Yumiko, for their support, my wife, Michio, for her patience, and our 2 wonderful kids, Setoka and Haruhiko, for being here tonight. Once again, thank you, AGU, for this great honor.
Congratulations, Motohiko. Our third and final 2013 James B. McIlwain medalist is playing a leading role in unraveling the extremely complex, multi-phase atmospheric chemistry of organic molecules emitted by both anthropogenetic activities and biogenic processes. This is work that significantly impacts research into adverse health effects attributed to poor air quality, as well as the direct and indirect effects of submicron aerosol particulate matter on atmospheric radiative transfer. Please welcome Jesse H. Kroll.
Thank you. So I'd like to start by thanking my citationist, Chuck Kolb, my letter writers, and the AGU for this great and unexpected honor. I consider myself really lucky to both to be here, but also luckier still to have worked and to continue to work with so many impressive and generous people in the atmospheric chemistry community, which is a really wonderful community to be a part of. There are way too many people to thank here, students, lab mates, and colleagues. But I do want to specifically acknowledge all the members of my group, as well as my 2 closest scientific collaborators, Kevin Wilson and Colette Heald, all of whom are a true pleasure to work with. I'm really fortunate to have had a strong and a rather large network of mentors and advisors from various stages of my scientific training. People who I learned a lot from, but who also remain deeply invested and supportive even after I move on. First is my PhD advisor, Jim Anderson, who really got me into atmospheric chemistry research, and who provided let's say, an ideal environment for thinking about how to carry out such research. My postdoctoral advisor, John Seinfeld, for giving me the opportunity to carry out some very exciting research in organic aerosol chemistry, and for being just infinitely generous with his time and his help. And then there are my bosses from Aerodyne, Doug Worsnop, as well as John Jane and Chuck Kolb, who really set up one of the most fun and intellectually dynamic research communities I've ever been a part of. And throughout it all was Neil Donahue, someone who was never my boss in a formal sense, but who has really been my primary mentor through my entire scientific career, and who is really the reason I'm in science today. Finally, I'd like to give my biggest thanks to my wife, Amy. I used up all my husband points a long, long time ago, but she continues to be an incredible source of great advice and strong support, and I owe her a lot. Thank you very much.
Congratulations, Jesse. AGU's highest award, the William Bowie Medal, was established in 1939 to honor one of the founders of the American Geophysical Union, as well as our first president, Dr. William Bowie. Dr. Bowie was an active proponent of international cooperation and geophysical research, and this year's recipient has provided others with not only the tools and technical leadership, but also the generosity of spirit to make such cooperation a success. His achievements in upper atmospheric physics, chemistry, and dynamics have revolutionized the field, produced significant impacts on other areas, including planetary atmospheres and atmospheric electricity. But he is perhaps best known in space physics and astronomy for the development of a model, now synthesized as the thermosphere, ionosphere, mesosphere, electrodynamics general circulation model that encompasses processes important to the upper atmosphere. Freely shared, this model and its predecessors have been used by researchers around the world to help interpret observations, explore interactive processes, and predict the behavior of the upper atmosphere under hypothetical past and future conditions. As a result, his unselfish cooperative efforts in research and impact on the field have been multiplied many times over, leading to an incredible volume of interpretive studies. Please join me in welcoming the recipient of this year's William Bowie Medal, Raymond G. Roble.
Thank you very much, Carol and Guy Bresseur, for this most gracious citation. It is a great honor to receive the 2013 Bowie Medal from such a prestigious and renowned geophysical society, and from my AGU colleagues. First, I would like to thank my thesis advisors, my co-thesis advisors, Paul Hayes and Andrew Nagy from the University of Michigan. It was a great privilege to work with these two outstanding professors. For my postdoc, I came to NCAR, the National Center for Atmospheric Research, in 1969, primarily to work with Bob Dickinson on the techniques of the meteorologist to develop a general circulation model of the Earth's upper atmosphere and ionosphere. And as Carol mentioned, it is known as, the current version of it is known as the thermosphere, ionosphere, electrodynamics general circulation model. This was a major task, so I collaborated with a lot of scientists, mathematicians, computer programmers, postdoc students. They participated in the development of the model by providing physical and chemical component codes, advice on numerical techniques, and guidance from experimentalists who required unique ways to process the model output for easy comparison with observation data. The model was available to anyone to use, and if desired, I would perform the simulation and structure the model output for easy comparison with data and also assist in the scientific analysis. Now, some of the people involved in this project are many. First at NCAR, Bob Dickinson, Cicely Ridley, Art Richmond, Ben Foster, Barbara Emery, Hanli Liu, Maura Hagen, Stan Solomon, Gang Lu, postdocs, and many students. And from universities, Paul Hayes, Andy Nagy, Tim Killeen, Fred Rees, Guy Bresseur, Susan Solomon, and others. And in data analysis, Gordon Shepard, Gonzalo Hernandez, Charles Barth, Henry Rishbess, Marty Malinzek, and many collaborators from NSF, NASA, and the Department of Defense on their satellite and ground-based programs. But most importantly, I would like to thank my wife, Mary, and my family for their gracious support throughout these years. Thank you.
Congratulations, Raymond, and thank you. Please join me in recognizing all our 2013 AGU medalists. Presiding over the honors tribute is one of the proudest moments in any AGU president's tenure, and this evening has certainly been a highlight for me. Chris McEntee, Margaret Linen, and I want to thank you for joining us this evening to honor these 83 truly extraordinary individuals. The AGU medals are among the most esteemed in all of geophysics and the highest honors bestowed by the American Geophysical Union. AGU medalists are extraordinarily dedicated individuals, and we recognize them for their scientific body of work that significantly advances the scientific enterprise. In the long march of scientific achievement, they hold the keys to our future. This year, 10 AGU medal laureates are being honored for groundbreaking contributions to scientific progress. The medalists have pioneered new frontiers in geophysical research through their creativity, original thinking, and groundbreaking advances in the earth and space sciences. They remind us of the enormous impact scientific innovation can have on the world when it is allowed to flourish. It gives me enormous pleasure to present these medals. These men and women are the giants on whose shoulders the next generation of scientists will stand. Their innovation and discovery have changed the way we view the world around us, and their achievements have benefited humankind immeasurably.